Today I want to discuss about the chemical bonding topic. In chemical bonding, now I want to explain about Fazan's rule. What is Fazan's rule? Fazan's rule. Fazan's rule discuss about the covalent character. Covalent explain about covalent character of the molecule, any molecule. What is covalent character generally? One of the important point remember always for covalent character, smaller cation and larger anion will form more covalent character. More covalent character. This is one of the fundamental principle of in the case of Fazan's rule. This is one of the fundamental character about the Fazan's rule. Smaller cation and larger anion will form the more covalent character. If you take any molecule, this is the condition must be applied. If you take smaller cation, if you take larger anion, take for example electrons. What is covalent character? Covalent nature means sharing of the electrons. Sharing of the electrons. Sharing of electrons. That is called a covalent character. How it will form covalent bond? By sharing of the two electrons, it will form the covalent bond. This will, smaller cation will polarize this bigger anion more. That's why this is having more polarizing power. More polarizing power. This will having more polarization. This is having more polarization. This is more polarized towards the smaller cation side. This is having more polarizing power. This is having more polarization. That's why this will, smaller cation will form the and larger anion will form more covalent character. This is one of the fundamental principles in case of Fazan's rule. Must be remembered. If you take some of the conditions of Fazan's rule, now I want to give some of the example. One more example, another important example. First one is smaller cation in case of, next size of cation, charge of cation, next not size, charge of cation. Smaller cation will form more covalent character and charge is more, cation charge is more, then automatically it will more covalent character. Next, one more example is, this is also one of the important point, PNG means pseudo noble gas configuration. C means configuration. Pseudo noble gas configuration means this is NH2, NP6 and 3D10. If any molecule shows this configuration, that will form more covalent character. This is also one of the most important point in this discuss. NH2, NP6, 3D10 molecule will form the cation will form the more stable covalent character. For example, if you take you take copper atomic number is 29. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 10, 3s1, 4s1. This is the copper 29 electronic configuration. This configuration is similar to this one. When we will get this configuration? If it is one single electron there, if it is copper plus, then it will gives this configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 3d10. This will show more covalent character, copper plus 2, because this obtained this electronic configuration, pseudo noble gas configuration will obtain. That's why this is form more covalent character. For example, copper, silver plus copper, silver, gold. Same similar like this, and this molecules also will form zinc plus 2, cadmium plus 2, mercury, zinc, cadmium, mercury. These are also same, we will get the noble gas, pseudo noble gas configuration. That's why this will show the more covalent character. Have to remember, this is also one of the important point. Three conditions must be remembered. One is smaller cation will form the more covalent character. Charge of cation, if bigger charge is there. For example, if you take any example, NaCl, BeCl2, AlCl3, which will form the more character. The anion is same. Then Al plus 3, beryllium plus 2, Na plus. This will form the Al plus 3 will form the more covalent character because size is bigger. Smaller charge of the cation is more. If you take in this case, which one is more? If you take for example, for any smaller cation, KCl, NaCl or BCl, which one will form? This will form the more covalent because this is smaller size. This is one of the example. This is for example. This is the one of the important points you have to remember. Pseudo noble gas configuration. Whenever the molecule obtains this configuration, it will form the more covalent character. This is about the in case of cation. If in case of anions, first point is, what is the condition first? Bigger anion, larger anion will form the more covalent character. Larger anion. The second point is charge of anion, bigger charge of anion. If it is more charge, more will be the covalent character. These are the two conditions in case of anions we have to remember. If it is case larger anion means, for example, NaCl, NaBr, NaI, sodium iodide, which is will form the more covalent character. Bigger the anion size, bigger will form the. If in case of charge of anion, if it is in case of charge of anion, which one will form the more covalent character? For example, if you take in case of anion, if you take any bigger anion, then monovalent, in case of divalent atoms, you can remember easily. If it is more, charge of the anion is more, then it will automatically more will come. These are the minimum about the Fazans rule. What is the, in case of Fazans rule, must remember always smaller cation will form smaller cation and larger anion will form the more covalent character. Fazans rule tells about the covalent character. This condition is must be have to remember. Next, after that, in case of cation, in case of anion, these are the two conditions, two different things. After that, in this case, what will happen? If it is any molecule, covalent character will be more. Automatically, solubility is less. Solubility is less means melting point and boiling point will be very less. Next, after that, these conditions you have to remember. If covalent character, ionic compounds is more soluble. Generally, ionic compounds will be more soluble. Covalent compounds is less soluble. Less soluble means the melting and boiling point will be also less. This also you have to remember, because covalent compounds is, ionic compound is 2. What is melting and boiling point? Ionic compounds, if we want to evaporate, it will require more melting and boiling points. But in case of covalent compounds, solubility also less. They cannot soluble easily. Then they can easily evaporate, melting and boiling point. Most of the covalent compounds exist in gas state. That's why the melting and boiling points are very less. If you take any example, some of the example, which one is more higher melting points and boiling point. For example, if you take beryllium fluoride and magnesium fluoride, if you take which one is more covalent character, which is having higher melting point or boiling point, whatever molecule, first you have to find out the covalent character. Which one will more covalent, then it will have less boiling point. For example, which is less boiling point or melting point? Which one? Beryllium plus 2, magnesium plus 2. Beryllium and magnesium, which is more covalent character, smaller cation will form the more covalent character. More covalent character. More covalent means less boiling point. This one is the answer. Same, based on this, we can answer any questions. This is about the Fazans rule. Now, once again, I want to explain Fazans rule. What is Fazans rule? Fazans rule means smaller cation, larger anion will form the more covalent character. It tells about the covalent character. In case of cation, smaller cation, it will be more polarizing power. Larger anion will more polarization. Next, second point, in two cases, one is in case of cation, charge of the cation is more, not size, charge. Once again I will repeat, charge of the cation is more, then it will also more charger will be more covalent character. In case of pseudo, one more thing is pseudo noble gas configuration. What is this? NH2 NP6 ND10. This any molecule, this shows any element or any molecule shows this configuration, it will be the more covalent character. Especially in two cases only, copper, silver, gold plus zinc plus cadmium plus mercury plus. These are show this configuration. That's why this is having the more covalent character. If covalent character is more, solubility is less, melting and boiling point also so less. If any compound is given, you find out the covalent character. Based on that, we can identify which is more covalent, which is having less boiling point, which is more boiling point. Then we can easily identify. This is about the Fazans rule. Next, one more topic I want to explain in this chemical bonding about Lewis dot structure. This is also one of the very important topic. Lewis dot structure. This is also very one of the important. In case of if you identify any structure, you have to draw any molecular structure. This is also very important. In this case, some of the conditions we have to must. For example, if you take CO32 minus, NO32 minus, NO3 minus, if you take SO3 2 minus, how we draw these structures, Lewis dot structures. In case of carbon, oxygen, 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 we write it. This is the negative charge. How we can write? Which one is central atom? Which is how we get this charge, negative charge? How we get the which one is taken as a central atom like this? In this case, some of the condition must be identified. Lewis dot structures. You can understand easily. First, to structure means outermost electrons. In case of octet, you have to follow the octet rule. In this case, first you have to remember. I want to explain some of the 4 points rules. Based on that only you can identify easily which is more easily draw these Lewis dot structures. These are also very important. First, if you take for example CO3 2 minus, carbon O minus and minus double one. How we this? First we have to find out central atom. How we can identify the central atom? Rules for selecting first. Rule for selecting central atom. First of all, how we select the central atom? In case of central atom, first least electronegative atom. Next, if it is in case of least electronegative, those atoms are least number. Next, third point is next size is largest. In case of if identify size is largest, any of these conditions, size is largest, atomic number is highest. Least electronegative, least number of atoms are least, size is largest, atomic number is highest. In any of these conditions is satisfied, then we can identify the central atom. For selecting of central atom, we have to identify this one. First, next, second one is generally hydrogen and fluorine will never act as a central atom. Will never acts as central atom. Hydrogen and fluorine will never act as a central atom. Next, if you identify carbon atom, octet of carbon atom will complete. Octet of the carbon atom will complete. Means in this case, this carbon atoms will complete their octet configuration, octet rule. Central atom must have 8 electrons or octet or more electrons. Central atom will not only follow the octet, it also extend further also, it will more, depends upon the number of atoms attached. Next, central atom tries to more covalency. Covalency means, what is covalency? Covalency means the combining capacity of the atom. Means its group number up to, in case of carbon its covalency is 4, in case of sulfur its covalency is 6, like that. The how many atoms it will combine, then it is also the covalency. In this case of central atom, it obtain more covalency. Which one is generally exhibit the central atoms means oxygen, sulfur, nitrogen, chlorine. Examples: oxygen is 2, sulfur is 6, nitrogen is 5, oxygen also 6 also, chlorine is 7. 7th orbit means 7 valence electrons. This is the second period. That's why These are the having the covalence. This is the rules for the identifying the atoms. For central atom, rule for selecting central atom is least electron number, number of atoms will be least, size of the largest, atomic number is highest. Which is any of these conditions we follow, then we will select it as a central atom. If octet means all these carbon atom must be in complete the octet configuration. Central atom must have 8 or more electrons. Octet it will be completed octet and also more. Central atom try to obtain maximum covalency. These are the 4 conditions to identify the Lewis dot structure of any molecule. One more structure, one more is if this is also important words. If positive charge is there, it is on central atom only. Positive charge is identified, it is there on central atom. For example, ammonium plus 3, H3O plus. This is considered as on central atom. If positive charge is there, that is considered. If negative charge is there, it is on corner atom. These 2 conditions also must we have to remember. If positive charge is there, it is on central atom. If negative charge is there, it is on corner atom. If you want to calculations, for example, if you take these are also you have to remember. Question. How to calculations formula. This is also important. Valence electrons of all atoms minus plus minus negative charge minus positive charge valence electrons of all the atom plus minus positive charge minus, if it is plus is there, positive charge. Bond pair electrons is equal to bond pair as 2 into number of bonds. Lone pair electrons is equal to Q minus bond pair electrons. This is also how to remember if you want to calculate the structure of the atom. If you want to calculate Lewis dot structure, Q is equal to valence electrons of all the atoms plus minus negative charge plus minus plus positive charge. Bond pair electrons is equal to 2 into number of bonds. Lone pair is equal to Q minus bond pair electrons. If you want to take identify any molecule, for example, if you take H3O plus, for example, how to identify which one is the central atom? Oxygen is the central atom because this is the highest atomic number. How we identified? This one hydrogen, 3 hydrogens are there. If you want to calculate Q is equal to how many valence electrons? In case of oxygen, 6. 6 into number of valence electrons. Positive charge must be in central atom. Plus negative charge is 0. Minus positive charge is 1. 6 minus 1, 5. Bond pair electrons is equal to number of bond pair. How many bond pairs are? 1, 2, 3. 3 means 6. Lone pair electrons is equal to number of, how many lone pair electrons? Number of bond pair electrons minus number of lone pair electrons. Number of Q minus bond pair electrons. Q is 5 minus 6 equal to minus 1. Not like that, this is not there. valence electrons of all the atoms. That is, yes. Plus 3 into 1 minus 1. Then 8, 6. 8 minus 6. Then it is 2. How many electrons? Yes. 1, 2. 2 means, yes. One lone pair 1 is small one. Yes. This is one of them. This is valence electrons of all the atoms. Valence electrons of all the atoms. This must you remember. Means oxygen is 1. This valence is 6. 1 is there. Plus 3 hydrogens are there into valence is 1. 3 into 1. It is positive charge. Positive charge means minus 1. That's why 8 bond pair electrons 1, 2, 3. Total 6. Lone pair electrons is equal to Q minus bond pair electrons 8 minus 6 is equal to 2. Then it is 2. Positive charge is always on central atom. In this. If you want to take another one more Lewis dot structure, ammonium plus. If you want to keep nitrogen is valence electrons is 5. 5 into 1 plus 4 into 1. 4 hydrogens, which is valence electrons is 1. Positive charge is minus 1. Bond pair electrons is equal to how many bonds are there? Nitrogen plus 1 positive charge in central atom. For 8 bond pairs are there. This is 8. Lone pair electrons is equal to Q minus bond pair electrons. 8 minus 8 is equal to 0. No lone pairs. Yes, this is the exact structure of the molecule. If you take one more example, for example, NO3 minus, for example, NO3 minus, we can identify anything. In this case, if you take nitrogen, we don't know how many double bonds or triple bond. This is the general structure. Identify. Q is equal to how many, which is the central atom? Nitrogen is the central atom because it is the least number. Next, nitrogen central atom 5 into 1 plus 3 into 6. Why is it 3 into 6? Each oxygen will having 3 into its valence electrons is 6. Minus 1 means it is having plus 1. 18 plus 19, 24. Lone bond pair electrons is equal to how many? 1, 2, 3. 3 bonds are there. 3 to just 6. 6 electrons. Lone pairs is equal to Q minus bond pair electrons. 24 minus 6. 18 electrons. How we adjust? 18 lone pair electrons are there. 1, 2, 3. 1, 2, 3. 1, 2, 3. 6, 6, 6. Yes, 18. 18 into what is the minus? Where do you have to put? How we put? How? That is the question. In this case, you have to. This one is 1. This is 2. This is 3. This is 4. In this case, you have to calculate the formal charge. Formal charge is called valency minus lone pair bond pair by 2. This is very very important. How we want to calculate the formal charge, then only we can identify the Lewis dot structure. Formal charge is equal to valency minus lone pair minus bond pair by 2. If you want to calculate the formal charge of nitrogen, first atom nitrogen, formal charge is equal to how many valence electrons are there? 5. Lone pairs are any lone pair is there nitrogen? There or not? How we find out? No, already 18 is there. That's why 0. Bond pair 1, 2, 3, 6. 6 by 2. Bond pair across 1, 2, 3, 4, 5, 6 by 2. Minus 6 by 2 means minus 3. 5 minus 3 means plus 2. Yes, it is plus 2. Can can write no problem, plus 2, no problem. If it is plus 2 or plus 1, exactly, what will happen, actually, this double bond is converted to bond actually, then only it will minus 4 by 2, 1, 2, 3, 4, 4, 8 by 2, then it will becomes plus 1. Why this in double bond won't? Because it in lone pair. One lone pair is considered as in this case lone pairs is either double bond and also triple bond. Considered as a lone pairs as considered as a double bond and triple bond. Why? Because this nitrogen is not 3 bonds. It will form actually 5. Covalence is 4. It will form up to 4 bonds. Then only that's why it is forms the double bond. Then it will, okay, no problem. This double bond is converted as a lone pair is considered as a double bond. That's why it is asking the plus 1. In case of if you want to calculate formal charge of third one, how will we do it? Valence electrons is 6 minus lone pairs is 6 minus how many bonds are there? Valence electrons minus lone pairs. Lone pairs are 6. Bond pairs is 1. How many bond pairs are bond pair is there? For this oxygen bond pair electrons by 2. Six minus bond pair electrons is 2 by 2. Generally consider 6. 1. 6 minus 7 minus 1. Here we get minus 1. Next is here also we can calculate it. NO3 minus NO3 minus already is double bond there. Yes, NO3 minus. If you want to calculate this one, here we get plus 1, here we get minus 1. Then it will all double bond. Only this one is the structure, then it will obtain easily. I want to explain one more time. In this case, NO3 minus. For example, if you take easily, I want to clearly explain NO3 minus. What is Q? Q is equal to valence electrons of all the atoms plus minus negative charge atom minus positive charge. This is the first definition. Q is equal to valence electrons of all nitrogens 1 plus 6 into 3. Negative charge is 1, that's why it is plus. Total is equal to 624. Bond pair electrons is equal to number of bonds. If you take nitrogen, oxygen, 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 generally we have to take this one. Number of bonds 3. Now normally we have to, for this sake of number of bonds, it means 6 bond pair electrons. Lone pair electrons is equal to Q minus bond pair electrons. 24 minus 6, that is equal to 18 electrons. This is also considered as a lone pairs and also considered as a double or triple bond. In this case, have to nitrogen is not 3, it is 4. Generally, we have to, if it is, this is also, if you consider all the lone pairs, it will be 6, 3 is 18, it will come. But in this case, nitrogen never form 3 bonds, it will form 4 bonds. Hence, its valence is up to nitrogen will form 4. Then how to find out which one is having negative charge, then we have to identify. In this case, how we can identify? We have to identify the 1, 2, 3, 4. So in this case, we have to calculate the formal charge. Formal charge is equal to valence electron minus, what will happen? Lone pair electrons minus bond pair by 2. This is the one of the important formula you have to remember. If you want to calculate the formal charge of oxygen 1, how will valence electron 6 minus lone pair electrons amount వచ్చేసి 6, bond pair is 2/2, 6 minus 6 is minus 1. In this case we get minus 1. If you take formal charge of oxygen 2, how we get number of valence electrons 6 minus how many lone pairs 4, bond pair 4/2, 2, 6 minus 6 0. Here we get 0. If you take formal charge of third oxygen, how we get same like this only. Here also we get minus 1. Next we have to formal charge of fourth nitrogen. Valence electrons is 5. Next minus how many lone pair is there? No, nothing is there. 0. Minus bond pair 1, 2, 3, 4. 8/2 means 4. 5 minus 4 means plus 1. This is plus 1. Plus minus, then it will form double bond. This oxygen will be the nitrogen. This is the Lewis structure of the NO3 minus. We can identify easily. Now close the topic here.